video. Remember, when I come up with a theory, I have to also try to prove it, and while proving it, I also have to try to debunk it. In other words, come up with another form of failure. I'm working on this one right now. All the cars falling, collapsing at the same time, trying to evaluate it from different angles, shear planes, which cars didn't fall at the same time, which would be this one on an angle here. Looking at this coming down here, wait a minute, what is this? There's a shape where cars back up to. It's a gap. Oh, gap from this wall here. This is the basement side of the garage parking area. If you're in the basement where we look through. Oh, wait a minute. We have a crack here, a bending moment. Huh. Okay. Cars underneath. It hit the cars and bent. I come back over here. There is a lot of shrubberies. Oh, there's these planter boxes. These planter boxes are developed. They're set up, but they're not block all the way down to the ground. They're not columns in the ground. They're planter boxes. Okay. Still, there's the vehicle, the car here. No planter boxes here. Let me go over. Hold on. Google Earth shows the planter boxes, and a little deformed, but here's the planter boxes in line with the structure. This is approximately 20 feet out. Let's go to the original drawings, and that's about right. So here's our original drawings. But take note of the column configuration. Again, we're going from here to here with no columns against the back wall. It's ledgered. It says property line. It becomes ledgered from here to here. This is where the vehicles are parked. Also, where we get that wrong picture. Right here, where it looks like it's a deflection from where it was connected here to here, but a fracture. Now let's come back to there. So we have no columns on the back wall. They ledgered it on the back wall. We got vehicles going back there. Let me see if I can put this to rest a little bit. Someone's comment about fire. These are designed to take fire trucks on top of them. Parking garages are. That's in your own mind. It's designed that way. That's a bias. We refer to as a bias. Clearly, it's designed to take fire trucks to go on top of it. That's a terrible bias on your part that you need to evaluate and delete from your files. Fire trucks and trucks you see on the road, just because you see them there doesn't mean a fire truck is the load-bearing capacity. Look at the comments there under the previous video. You'll see somebody, I don't want to steal his thunder, he did the best comment. And he's talking about how in 1926 we were up to 100 pounds per square foot, and then you drop down in loads. Now we're down to human weight. And I said that trolling engineers here, and I got one engineer to troll me back saying, no, that's code 40 pounds per square foot. Well, that's human load. A car clearly creates more than 40 pounds per square foot pressure load underneath the tires. Clearly creates that, or should I say can and does create it. The based on tire pressure, contact points, stuff like that. The higher your pressure, the less your tire pressure increases. That gives you less contact point on the surface, which increases your pressure. And if we go to granite, fire lane, whatever the hell this article is, you look it up yourself. I like how this person clearly states that you can get up to 322 psi once you put those pads out for the fire truck. So the fire trucks just don't put out their pads. They got to evaluate the street and where they're going to put their pads out. I've got a man lift. I have to evaluate that man lift, that when I put those pads out, that it's going to be stable there. Once I put the lift up, it changes the pressure on each one of those feet. They're not, just because it says I can go this way and that way, it doesn't mean the pressure doesn't change on those feet. That changes on those feet, and I could tip over. You guys sent me the crane videos. Yeah, well, the pressure of those outriggers changes. For example, this truck distribution weight appears to be more in the back, but keep in mind there's more weight back there. There's how you load a vehicle determines how much pressure on there. All right, I don't want to go down there too much. Just want to tell you that it matters. A little small vehicle like this, it matters. How it's the securement into the existing columns, it matters. We have a weak deck. What I want you to notice, what we don't have, and I've been, you know the way I preach, the way I do it. So what we don't have is, where the heck is it? What we don't have is what everyone talks about right here. Look right in front of your eyes. I'm trying to give you the tip ahead of time. What don't you observe right here? For all my people that, I do delete the comments to take it off the narrative. All right, Google taught me that. I learned to adapt. Google says if you, a lot of them I do, a lot of them I keep up, but some of them are too strong in their trolling comment. They don't realize the psychology behind their trolling comment that's so good that I'm like, no, you actually did the right amount of trolling that would get in somebody's head. So some of you guys, for the trolls, do so good that you get deleted. The other trolls get released and maybe a comment put on them. But I won't tell you your trick on your troll because I don't want to teach you. But I want you guys to look at this image, what you observe here. And think about all the many comments that are going down this line of rebar failure and water penetration and weak deck. What don't you observe here? You don't observe a fractured deck everywhere. What you observe is a fracture in the middle, the span here. But puncture is what took place. It dropped down around this column. See the gapping, releasing. Because the pressure of these cars have to be resolved where? Not in the deck. It has to be resolved where it meets the column and then transfers down to the foundation, whatever foundation the pile of the system they used. But this is our transfer over to the columns. It couldn't take it, and that's where you get puncture shear. I pronounce it puncture, making it a short abbreviation of it. Look to your left here. You see this is where it is and is not connected to the wall system. So you have when you have this load resolving itself in the middle, the greatest. Let's see if I can do this. So the greatest loads are from here, from wherever this column is. It's one right there. There it is. So that's a column, puncture, and there's one over here hiding. There's one. They're offset, if you recall. They start doing this jogged offset shit over here when they get over here. Column right here by my mouse. I try to find how to change the mouse on this Mac. I got to look longer into it. Sorry, guys. Right here by my mouse. I'll make this bigger. And a column. And then an offset column. And then an offset column. So your spans, as I talked about in another video for supports, get greater. The reinforcement doesn't seem to get greater or more strong. These obviously have reinforcement all the way around them. But here's our load that I believe started this reaction. And so we get, and there's the car leaning a little bit. So we get this load, and somebody's talking about this truck, etc. I'm going to talk to you about snowplow loads, I call it. Another engineer taught me when I was younger, said he calls it hydraulic jackhammering. I like my snowplow forces, and I'll explain snowplow forces to you. And I'll do a video of that, making it very simple for you to observe. I'll do one of my real life videos in the world. And then you'll see it, and I'll show it to you in the streets. And you'll say, oh, yeah, I see it. Well, those forces exist here, and they're always straining, pushing and pulling on the rebar. This rebar being very weak and pull-out tension reduces the amount that how it can hold. There's no shearing took place here. This is more pull-out failure. No shearing. We don't see the rebar fail and shear. We see the rebar fail and pull-out. That would be, no, your pull-out test. I'm going to get you guys some pull-out tests. Pull-out test. Oh, I can say a lot of bad things about that. But let's go here. Pull-out test. Thought I had a video of it for you guys. These are the type of toolings that tells you how your concrete's interacting with your connection there. Obviously, the pull-out, the concrete and the columns. If you take note of this, guys, I want you to learn this one. Take note of the columns. If I'm telling you a pull-out test exists, and it shows you how it interacts with the how it can pull away, how you can determine concrete strength by a pull-out test. Then I want you to show free Bitcoin. So I want you to understand this also. Take on the data. That what do you observe at these columns? You observe the concrete columns are not having the rebar pulled out at these columns. The rebar is in place. It's not pulling it out and destroying it by the columns. Where it is pulling out and failing is at the deck under deflection load, it's just ripping its way out of that low cover. Now, I know people are going to point me to ACI and everything else. That's your God. ACI is not my God. All right? ACI is not my God. ACI is a guidance, and yes, a lot of municipalities say follow it because everybody loves to fall back. Hey, you can blame ACI. We're not taking responsibility. Clearly, though, a pull-out test should be required on all structures when building to do the to evaluate your concrete interactions. Now, I'm going to piss off some professional engineers that rely on programs, specifically probably a couple of them that called me up. All right, I'm using real common sense here, engineering, old school Benjamin Franklin type stuff. Not, you know what? I'm following ACI. I'm doing this. You sound like a fucking doctor at that point saying, there's nothing we can do for you. You're dead. All right, this is the best we can do. That's it. That's the limits of my ability, is what it says there. They lack logical thinking after that. So logical thinking should have all engineers doing videos saying, hey, check this out, guys. Look, pull-out failed here, but it didn't fail at the column. Because at the columns, we have the rebar sticking out. So at the columns, we have rebar sticking out. So what does that tell you? And you could actually, before this, you could actually cut this, straighten that rebar up a little bit, and try a pull-out test on it while you still had a chance. Very dangerous, but you could do it at a distance because you have hydraulic hoses that you can do it and come up with the answer. You could have evaluated that before, but without that said, you can still calculate the dead loads of the concrete here if you knew the thickness. And the vehicle, you take down the serial numbers and see nothing's heavy inside of them, and you could come up with a pretty good load calculation saying that this weight from here to here, dividing it up based on the rebar, goes this way. No, if it's not two-directional reinforcement here, now we got a rebar going just this way, in this direction, which we see in the images, the rebar going that way underneath of here where it's collapsed. Now the mat might go that way also, but it's near the bottom. It's kind of like, but if it's going this way, of course, rebar in that direction would make it weak in the middle here because there's nothing to help reinforce it going the other direction. So we have minimum rebar going this direction. I really got to show you this, and I really want to put this video up, and then I'm going to start helping you understand rebar in two directions. It's going to take me a minute to finally get the aha moment for you guys, but you know the way I work. Bear with me, and it'll pay off. Here's the entrance to the walkway over here. Here's my mouse. Sorry about I can't change the color here, magnifier. And then here is some shear going on. I don't see rebar sticking out. It appears it was illegal to use rebar in this building. I'm being facetious. So here is that bump out here. That bump out is represented, and over there also. So I'm simply saying you have your rebar is at the bottom placement. Yes, I know a couple of you guys are so bright that you're telling me that's where it's supposed to be. It's not supposed to be at the very bottom. Now, with that said, you can reinforce a structure by putting reinforcement literally at the very bottom. And what you would do is use like carbon fiber wrapping, things like that, to help strengthen it. So there is some substance to that. Take note of the parking right here. There's the columns. They made a no parking zone. This reinforcement around here seems to be right there's that column, the column with the concrete that sheared right there and left that part of that part I just stated. It left it up, as you can see it right there. Right here, this piece, the double lines in Google Earth, that's Google Earth I'm looking at, so it's deformed, however it's deformed. And then you see it right here on this side of the column left in place. So there's our shear plane created right at that column. When these loads happened, it broke here. This is where this flexed from here, though. So I'm confined inside here. These 6 cars being our load force, they cause the progressive collapse. So you get a progressive collapse. Didn't say it takes one piece onto the next piece onto the next piece. We know we have a progressive collapse in a timeline. Our epicenter, biasly so, is right here where I point, saying right down this line here. Our load that caused it, I believe, are the vehicle loading and the way the rebar is laid out. And remember, the pull-out test is so important. I really got to do some pull-out tests for you guys and show you. That little break here in this little planter box area pulled away from the structure. Let's see if I can get you. So here, the original drawing 79, and not 70, not 80, whatever it is. So, oh no, there it is. Revised May 14th, 80. It has the planter box in line here, and that appears to be roughly about thereabouts aligned with the current layout using Google Earth. Using Google Earth, there's the planter box. It appears to be about the same. So people are saying that why would they change it and add cars over there? Well, I don't find it. They changed that. What we do find is that again, these are the columns on the basement level going up. If this is the basement, this would be the pool deck area. That they configured the mat. The mat, not really. I'm looking, when I say mat in this case, I mean, I don't mean rebar mat. I mean the mat for the, I'm looking at this as a mat in my eyes, the reinforcement columns only. And you can see, if you stitch your eyes back, you see how it's gridded. But you see over here where we have an interaction with the building where it's a structure, obviously they're going to use taller beams there, more substantial beams rather. So we give them okay, that makes sense. That would be larger there. So don't get an aha moment there, except for the interaction around these columns would be more so than the interaction around here because there's car loads too. So you're going to get a little more interaction ability. I didn't say they did it. Rebar they'll be able to add into these columns to help support the deck. Did they do it? Apparently not. Out here, this mat, the concrete deck now. We have these smaller columns, these heads, they're placed on top of heads, rebar turn this way, form set up, and then they poured the deck and the heads integral to each other like a monolithic pour, I believe. I don't believe they poured the columns and the deck together. I believe they poured the columns so far up, then they poured a platform and they made the heads and the deck all in one. It'd be very interesting to see how they did that, this system. Or maybe they made the piers tie into the foundation. I don't know that till they take it apart. It'd be interesting to look at. We still get punk shear. Nothing really to see there besides did it work or not, because for future data, because we don't get these failing under buckling. So we have our loads over here where the cars are, the planter boxes, and there's some separation from the wall in there with the planter boxes. So we don't have it tying in back here. So we have the car stresses. Let's see, out to the second, out to here. Planter box, I think, turns here. So we have these car stresses wrapped around this column here. And then car stresses wrapped around this column here. So you get two cars here, maybe some of the third car transferring its load over. Not that third car transferring a load over to some degree. So we get a massive amount of more forces on this side than on this side. To pick up this side of the forces of the load of the vehicles, it appears to be no column row here. It jumps over here, which gives us a greater distance. It's no longer the same. It goes from here to here, from here to here. So this mat reinforcement has to make its way over to here to support the cars that are placed inside here. The good news is this car probably was closer to this column, so a lot of it will want to transfer to the back of the car, and they put engines first. You're backing in, works against you. That puts the heavier load of the cars out here, and the back of the tires being lighter puts it more of the load here. So take a load off, Annie, the song. So then you got this truck with the load, engine load there, engine load here, kind of different. This one's in, this one's out there, putting it more towards this column. So what do we have here? After evaluating all that, we still have a mid-deck failure between this column and here. I know we have the cars to deal with. But we still have punk. So we have punks here, and how do we get this deflection here? Biasly so, we could have cars parked here, and then this creates this butterfly effect, my bias. I still get my butterfly effect up to here. The pull stops the butterfly effect, so this is me debunking myself. Stops the butterfly effect because it runs into this part. Cars still being here possibly, and we know they're over here. So this would stop. This would create my butterfly here. We still get the puncture, but I create my butterfly in a different format. Crushed cars parked underneath of these cars, which we would need to see. But now they drop buildings on it. That's shit can data there. I don't know or not. And what are the odds cars are parked right there? Well, there might be pretty good odds there. The parking lot seemed pretty crowded, full when she was there. So then we get this. We still get puncture because we get the column stripped. The column stripped around there. I showed you the bevel of that one. I can't zoom in anymore. We get the, and then this gets the pulling effect back towards the building. I'm still pulling the deck down away from the building. This one is very telling to me. This piece of concrete that's fractured off the opposite direction. There's a pier there, right there. That's where this little lady here is I believe, let's see, so back, this little lady here. So somewhere about here is where we get that one there. So it's on an angle here. Let's do the angle. There's your back deck, and let's come back to, so there's your storm. I'm in line, and then I change over to a smaller column. Okay, there we go. So it's in line, it changed to a smaller column. This is in line, and then it doesn't change to a smaller column. It just shifts over to a smaller column. And you guys should see what it says. I mean, you see that, right? It's a shift over of 6 feet, 0 inches. They shift this load over. This one's a smaller one. I can't see it here. I can't make it out. I can't zoom in anymore. Wait a minute, I can. Oh, I can. This is a different drawing. Okay, awesome. I thought I was in a photograph. I'm in the thing there. So there's a shift of 6 feet there. There's a shift of 2 feet 4 before you get to that one. This is our, let me show me my car loading area. Yes, this is the car planter box here, car loaded area. And that puts so the distance is greater here, here. And there's a shift in the reinforcement having to make its way over to here. This was just one giant, let's just shift the friggin' thing over where we want to type deal. So you can imagine your reinforcement would still continue straight down, but your mat that you lay for puncturing shear, I just call it puncture, P-U-N-C, not T-U-R-E. It's puncture and punching shear. But there's a lot of abbreviations. CMU, concrete masonry unit, WC, water closet. Well, mine is punk shear, P-U-N-C. So yeah, you can troll me on that. Someone attempted that. I don't give a fuck about that, whether you don't like my abbreviation or not. Kiss my ass. So anyway, and that's KMA. Kiss my ass. So anyway, so your reinforcement mat. Imagine this mat. If I can draw lines here. Let's do that real quickly. And end the video so I can help you see. Okay, so I can pull this one up. They won't let me keep this. That's interesting. I'll lose this one. Maybe I want to go a little thinner than that. Let's see. Nah, maybe not that thin. All right, so imagine. Great. I need the hand to come up. Come on, hand. Where are you? Whatever. There we go. So imagine this mat, right? So I'm trying to make it so these two hold each other. I wish I could do a better one than that. Looks like I'll just have to make a bunch of these. Oops. So imagine that this reinforcement I have here is here, and then I'll add 3 more here, and we'll add 3 more. 1, oops, 2, 3. And I'm being light on my reinforcement here. I guess that's consistent with the structure. Let's do this. So let's add it there, right? So there we are. So, and it's on top of that column. Well, what's connecting this side to there? Nothing. That's where we get the cheese grater effect. It just rips down. So let's kind of stop that cheese grater effect. So let's go ahead and tie these together now so they act as one. But let's do the cheese grater. Let's put it on the outside. So I still get it. So I can still puncture around this column, can't I? So I can still puncture. Let's get closer to it. And you can get right up on it, you know, where it just slips off. You can get like right on it, but I don't want to block the column. Yeah, maybe let's do that. So I get that right on the line there, the cheese grater thing. Now let's add some more reinforcement for this one up here. Let's do. I'm sorry about the proportions. I guess I can fix them a little bit. So that's a smaller one, as you notice too. So let's push this up there. Let's push this one. Let's push it down there. Let's straighten this one up a little bit. Let's grab this one. Let's drop it down a little bit. So I'm trying to make it kind of equal there, you know, equal-ish. So then let's grab this one. Let's put one right next to it. You'll see I can pull it around. So let's do that. Let's make this one, you know, let's make this one kind of close to it. So now we got a smaller one. So which one's going to be easier to cause the fail? Well, you know it's going to be this one. It's the smaller of the two. As the cars are parked here, the loads on this side. We see over here it's missing a section of concrete. We see that with, you going to stay in the way? Better image somewhere else. Right here. So here's our concrete here, but we have rebar sticking out of that column, out of these columns. See the two pieces, 1 and 2, and you can go search those all you want. So let's do that. Let's put 1 and 2 in there. 1 and 2, and I don't know what the other one looks like, but this will help you recreate the issue here. Oops, can't get to that other one. It's gotta move this one out of the way. Oh, my increments, it won't let me. My built-in increments in this software won't let me put it kind of parallel to it. It jumps that much. So you're going to have to pretend like it's in there. So we see 2 pieces of rebar added in there, but it's inside here. And maybe it goes all the way through and it's on the other side also. So when this deck failed, this punctured down through around it. And it left this rebar here, so it shows that it fell together in unison, equilibrium. I love my term of equilibrium. Both sides falling at the same time, pulling at the same time, not one side pulling on the other, proves that, in the way they're deflected, proves their deceleration to the ground, if you will. What the hell is the image? So it would be that one. So you can see the rebar, this one went down further, and then here's the rebar in this direction. So they went together. If this went first, and this would strip it down, and you would see the numbers rubbed off, which we don't see numbers rubbed off. There's puncture together. Okay, so they puncture together. That's our togetherness. And over here we have the rubs that show the rotation of torque took place as the secondary zone took in the progressive collapse, and then back to the building, shaking the building, and we went from there. I don't think that crash shook the building. I think it just not in this that first part of this. The first part of this. When this came down, I believe this was probably progressive. This was first, ripping this around and torque, rubbing the numbers off, coming back to the building. That's when we get a vibration, and 7 minutes later we get the total collapse, but thereabouts. Now, how would you stop that? As part of the puncture thing is you make a mat. You know, you're going to really, you're trying to make this so it doesn't puncture around there. So you add more is better, right? As long as you get some interaction with your concrete, that your paste, not your concrete. I don't want to get that mixed up with the mortar that's needed to make this work, because concrete's just not stone and sand, and you need the paste. So now look what happens now when I do this. Now it's got a lot more in it with concrete there. It's interlocking. It's got a lot more it has to defeat. And there's many ways to this will look, but this is just a rough idea of one of them. So don't get too confused with that I'm crossing over the center on this one. The whole idea is to watch what I do here. So the whole idea is to make this mat, this design here, interact with the next mat. So let's do that. So then we do another one here. So let's see if I can help you out understand this. So then let's do another one, and this will be this version of it. Of course, the rebar really counts here. You pull out really counts because that's your deflection. You don't want deflection here. You don't mind some bouncing. You don't want fracturing either, because the cars are going to make the deck flex. And if a deck flex, you'll get fracturing of your rebar, of your concrete around your rebar, and you get failure from there. And you've got to redo your bridge decks and stuff like that. So now I've got two isolated things here. They don't really work, do they? Not together. So then I start tying it in with the rebar coming across here. Now I want you to notice the span between these two. Let's just use these two pieces here. Let's throw a third one in. So the span between these two, I'm going to make that one longer. And I'm going to change the color of that one. Well, that didn't work. And let's make it larger. Let's see, a bigger bar. Let's see, a bigger bar. And this one, and let's make it a bigger bar. Okay, I'm in red. So let's make that a bigger bar just for clarity. I'm already there, so tap on it, change the color. So let's make it a bigger bar, green, larger sizes. They're gonna deflect less. Just put them 12-inch on center in your mind, in your mind. So now, as you can see, as you load a vehicle, and let's make this our vehicle. This box, what color is it? Green car. Okay, works for me. And I should be able to move it now. Here's our car. Right on the middle. So what's it going to do? Like a rubber band. Think of these rebar like rubber bands. It's going to want to deflect down. And when it deflects down, oops. And do this. Okay, that was weird. Oh, I have it over here. That's why. And change color to red and go with a larger one. All right, and here and here. It's just, and I'm going to make a deflection like that. All right, so here's our car. It goes around there. It puts stresses on the rebar. Uh-oh, look at it deflect. What's happening here? It's pulling on these two ends. We don't want it to pull on those two ends, do we? So we don't want it to pull on these two ends. We want it to, purple? Columns. We don't want it to pull on the two ends, so the rebar should not slip. We don't want the rebar slipping, or it would do that, like in that other video I showed you. It would slip and start doing that. We don't want that. We want the rebar to stay, to be able to stay where it can take this load of the vehicle coming across. We don't want it pulling on here. But if it's not enough rebar, it pulls on it. And at one point, it pulls out. And if it pulls out, let's see if I can grab this thing out. It falls down like that. The cars are on it, punctures around the columns, and it falls down. There's my animation for you. How's that for my high-tech animation? So it punks down. So we want this thing to stay kind of flat. But that rebar being at the bottom rips out. Some of that rebar we see at that deck up here, it rips as that other deck goes down over here where the dogs are, a person with dog. It rips out, and let's see. Some of it rips from the ceiling and it goes down like that. And you see the rebar. Some of it rips out and you see the rebar in the other direction hanging out like that. But there's our little car action going on in our deflection. So let's do that again. Boom, the car hits. Without deflection, with this deck doesn't deflect, our punct shear happens where it just tries to rip it off. And that would create more like a shear. See that going straight up and down? That would shear that rebar, and it would literally look like, like you cut it. We don't have just sheared, we have rebar that's bent. So we have a rebar, however you, so that rebar we see in the image here, how it's shaped. You see it? It was only that direction. I don't see any other direction coming across. I could, this rebar, I could duplicate it over here somehow and try to figure out at what point it released. It released at that point before, and now it went all the way down here. So let me get this right. This rebar has some rebound in it. So it went down to there, and then it popped back up to here. So it went all the way down. This rebar went to there. That's when it finally released. So if I could lift this, figure out the length of this, I could figure out what point it released. And when it released, it sprang, like spring metal, sprang back up to here. Doing? Okay, I had to make the sound effect. So I hope that helps you understand this. Now, how do you stop that? You want this mat here to interact with this mat here without that deflection. If I start removing it, rebar, it's going to want to deflect more, bounce more. And that's going to keep working. It's cycling it over 40 years, including the rust breaking free. And I have to tie it. The way I do my videos, I got to tie all this stuff in. You just don't get what's inside my brain in one little video. I want to share it with you, but it's more complicated than that. The metal expands when it rusts, and when it expands and rusts, it loses its connection with the reinforcement around it. We could look at this to determine what happened here. If we could get close to this rebar and literally look at it and take dimensions of it, measurements of it, then we could say, oh, you can say water all you want, but there is no rust deterioration or expansion in this metal. So you go click, check that box off. This was not water deterioration by rust jacking on this. So check off the box. You can find the different metals matter. And I keep finding great metal here. I know we're talking about rust jacking. We see it in here and there, oxy jacking, as you guys want to look it up. Rust jacking is my old school name. I don't find this metal rust jacketed. I find a soft concrete where it keeps pulling out, and a lot of weak concrete where, I'm sorry, concrete's not weak. It's exactly what it's supposed to be. So concrete is, we've been told that it gets stronger in years, not weaker. But it can get weaker in years if you've got a lot of deflection going on, a lot of cycles of the cars going on and putting it under stress. Then you're starting to break the concrete apart. And if we look at the samples of that deck, where they took, and I have in the other previous video where you see the core samples, it's fractured in multiple places. So clearly the deck has been cycling for one reason or another, and we get these cracks. The rebar's still in place, but it needs the help of the concrete around it. So I'm going to move this into the concrete now. This no longer is a car now. This becomes concrete. So we put the concrete around this rebar, and let's say it's one section, not two pieces of metal. And as the concrete flexes, it starts working our metal, and it starts creating all these fractures in the concrete, losing its ability to be anything but a piece of steel you're trying to walk across with some concrete laying on top of the steel. I'm ending this video. I hope that helps you understand it a little bit better. Again, to make this work, you have to make it so it does not want to deflect. It acts as one mat and not puncturing around, your. I can't get hold of the one I want to get hold of. The one in the middle. Whatever. There, that one. Let's do that one. And can I get that one? Nope. Nope. My hand's too big. Let's just shift that down then. Get rid of it. Put this back. So we get this lack of reinforcement there, and that allows for easier puncture with the cycles of 40 years, which I was triggered by. That. So I get my friend, is another engineer, owned me. He said, I told her about the lady that said I should run the program. And he knows my amygdala theory too. Initially, he didn't, I look like a nut job when I talk about amygdala theory, but now he gets it. So he says, she owns you. She controlled your amygdala. I said, she owned it. When she said, use the software, own me. So it's nice. See, you got it. Come on, hand. You're supposed to switch over to the other. There it is. I want to straighten this back up. Even, no one's above being owned, because once you have a conclusive file, all I got to do to trigger you is attack your conclusive file. Anything you own. In my case, I own that software is causing a lot of problems in current analysis with engineers. It's stupid. It's artificial intelligence that is not intelligent. So we got 2 pieces of rebar in there that obviously is not enough to stop all those cycles over the years that happen to catch up with this deck just at this cycle, at this time. Take care, guys. Love you all. Hate the haters. I have no choice but to hate you. Sorry, that's the amygdala. It's kind of petty, but yes, the amygdala is petty. So yes, I know people said take the high road. You're looking at it from your side, my side. I'm being attacked, and so yeah, I have no choice. But the good thing now is I use my PayPal as my form of attack back. I can talk to you guys about amygdala stuff later, but I can prove to you, everybody can be triggered. There is no such thing as somebody who can't be triggered. For example, the engineer says use the artificial intelligence program to evaluate a 40-year-old building, is her conclusive file. So she's triggered when I attack her thousands of dollars worth of program and call it shit in this scenario. Take care.